Is a really important section, and I can probably guarantee you that you're going to have a question like this on the ACT. If you understand inscribed right triangles and the shortcuts on how to solve different side lengths, you're going to breeze right through this question and move on to the next one and give yourself more time on ones that are a little harder. Okay, so before I jump into the content, I think it's really important that you guys understand how to reduce or simplify radicals. And if you've not, you should have seen this by now, but I want to review it. First off, when I'm dealing with the square root, everybody know what the square root of 9 is? 3, right? Okay. What about the square root of 27? How do I simplify that? What's that? 3 square roots of 3. Okay, so I want to go through the process of how to do this just to make sure everybody understands, because in this section and beyond, all of your radicals will have to be simplified to get the answer right. Okay, so if you get the answer, the square root of 27, that's the answer. If I wanted it in a decimal, you take the square root of 27 and then put it in your calculator and then tell me the decimal. But if I want it as a simplified radical, what you do is you look for a perfect square that goes into the number, that's a factor of that number. And remember, your perfect squares are 1, 4, 9, 16, 25, 36, 49. They're just the number squared, 1 squared, 2 squared, 3 squared. Those are your perfect squares. Okay, so I need a perfect square that goes into 27. What is that? Perfect square that goes into 27. What are your perfect squares again? I just went through them. Okay? 9, right? 9 goes into 27. So I could reduce this to the square root of 9 times the square root of 3. The square root of 9 times the square root of 3 is the square root of 27. And the square root of 9 is 3. So simplified, this is 3 square roots of 3. Okay? This is the right answer. This is the more right answer. And this is the one you need to be able to get to. Okay? We'll do more as I go through some examples with the actual material in this section. But if you are still struggling with simplifying radicals, you need to practice that, because you've got to be able to do it in this section. Okay? So again, you're always looking for perfect squares that are factors of the number in the radical in order to simplify it. Okay? So one concept in this section is if I'm given a right triangle and an altitude, this will always create 3 similar triangles. Always. A right triangle and its altitude. And I'm going to go ahead and label, just to make this a little easier. The easiest way for me to figure out that similarity statement and those 3 triangles is to draw them all in the same orientation, right next to each other. Okay? First, does everybody see the 3 triangles I'm talking about? You have the big one, and then you have the two triangles that are created from the altitude. Okay? So I'm going to draw the big triangle first, and I'm going to do it in this orientation. And then I'm going to draw the smaller one and the smallest one. If you're someone that can just look at it and see it, more power to you. Don't do what I'm doing. But it can get kind of confusing trying to figure out which side it is that's corresponding to which side. So I always, and I would recommend that you do this until you see it, I always draw just 3, I just jump right away. I draw 3 triangles. 1 big one, 1 smaller one, 1 smallest one. Okay, and now I'm going to label it. The vertex of the big one that corresponds with the right angle is B. The vertex of the medium one that corresponds, this is the medium one. Maybe that would help. I'm going to make this 1 and this 2. This is 1. That's 2. That makes sense? The vertex of number 1 that corresponds with the right angle is D, and the vertex of number 2 that corresponds with the right angle is D. Everybody with me so far? Now, if I'm going to label this A and C, so what I'm looking for here, the easiest one for me to see here is angle A in this triangle corresponds to angle A in triangle 2. So I'm going to put it in the same place. You see that? Okay, so my big triangle, I just picked whatever three in whatever orientation. I'm going to set this one to be whatever I want it to be, ABC. Now I'm going to look at the next two and look at corresponding angles. Okay, so angle A is common to both the big triangle and triangle 2. And because angle A equals itself, it's going to correspond with itself. So if I put angle A in this position, I must put angle A in that position in triangle 2. Now does that make a little more sense? Okay. In the same manner, angle C is corresponding to itself in both triangle 1 and the big triangle. So C is here, C must be here. Now I can fill in the missing vertices with the missing letter. So the first triangle, 1, is BDC. I have DC, so this must be B. And triangle 2 is ABD. I have AD. This must be B by process of elimination. Follow me? It gets confusing if you don't have some sort of a system to do it for you. And this is my system. If you've got a better one, use it. But I need all the triangles to be in the same orientation, and I easily can see A corresponds to A, C corresponds to C, and then I just fill in the missing letter. So now I can write the similarity statement. Triangle ABC is similar to triangle DBC is similar to triangle, BDC. I have to do it in the right order. Triangle ADB. Now I have my similarity statement. Once I have my similarity statement, I can create proportions to figure out missing parts. Okay? If this is 3, and this is 2, and this is x, as an example, I can say AD is 3, DC is x, BD is 2. So now I can say 2 over x equals, no, I can't. Can't do it that way. Can I figure this one out without another side? So let's just say that's 4. AB. Will that help me? Well, here AB is 4. And I know AC is 3 plus x, right? This whole length. So now I could use these two triangles to write my similarity statement, or my proportion. I could say 4 over 3 plus x equals 3 over 4, and then cross multiply and solve. Okay, so once you've got these triangles and they're correctly labeled, it makes it easier to set up your proportions and solve for sides. Okay, but there were 2 shortcuts presented in the section. Okay, and they both have to do with geometric mean. And the geometric mean is not the arithmetic mean. What's an arithmetic mean? When you hear the word mean, what do you think? That's median. Average. Okay, the arithmetic mean is the average of whatever numbers you have. Geometric mean is not. If I want to know the geometric mean between two numbers, 3 and 7, I want to know the geometric mean. The geometric mean is the square root of the product of those two numbers. That's the definition of geometric mean, the square root of the product. Arithmetic mean is the average. geometric mean is the square root of the product. Okay? You need to know what geometric mean is to use these shortcuts that we learn in this chapter. If I'm given an inscribed triangle, there are two shortcuts so you don't have to draw those three triangles to figure things out. Let's call this B and this C. One has to do with the altitude. The altitude is the geometric mean of the two parts of the base that it creates. Say that again. The altitude is the geometric mean of the two parts of the base of that big triangle that it creates. Okay? So if I go back to this triangle and I had 2, 3, and x, right? I know the altitude is the geometric mean of the two parts of the base it creates, and then I can solve and figure out x without having to worry about any of those similarity statements and drawing my triangles. That's just a given. The altitude is the geometric mean between the two parts of the base it creates. That's the first shortcut in this section that will be helpful to know. The second has to do with the two legs of the triangle. Remember, a right triangle has two legs and a hypotenuse. So the second shortcut has to do with the two legs. And the shortcut is the leg of a triangle, of a right triangle, is the geometric mean between the part of the base closest to it and the whole length of the base. The part of the leg of the part of the hypotenuse, if you will, part of the hypotenuse closest to the leg times the whole length of the hypotenuse. And then, given that it's true on the other side, what do you think F is equal to? Square root of C times the whole length. Okay, so let's do just a quick example, and then we'll go through the textbook check. What is the altitude? Square root of 3 times 4, which is? Okay, but it's not simplified because a perfect square goes into 12. 4, so it's 2 square roots of 3. I'm going to teach you a trick on how to simplify the geometric mean a little faster. Don't multiply them. Keep them separate. Then it's easy for you to see the perfect square, right? If you go further and multiply them, you're going to end up unfactoring it eventually anyway. So just do the square root of each factor separately. You'll get the same answer, and it'll be a little faster. Okay? So how do I figure out y? Three times 7. You add them. Now, neither one of these are perfect squares, so it's not going to do me any good to do them separately. That's just the square root of 21. Right? Now, z, the side closest, times 7, right? So if I do this, this is really 2 squared roots of 7. Or the square root of 28, which then I would have to simplify to 2 squared roots of 7. So it's just easier to do it as you go. That makes sense? Okay. If you forget these formulas, you can still figure them out for the most part. There's going to be some that you won't be able to without the formulas, by breaking it into 3 similar triangles. This is a lot more work than just remembering those formulas. So the altitude is the geometric mean of the 2 parts of the hypotenuse. This leg is the geometric mean between the part of the hypotenuse closest to it and the whole length of the hypotenuse. This leg is the geometric mean between the part of the hypotenuse closest to it and the whole length. If you remember those 3 shortcuts, or those 2 really, because the legs, it's the same process, just different sides of the triangle, you'll get yourself 1 more point on the ACT. And you'll do it really fast, rather than having to break it into 3 triangles and confusing yourself on how to do that. Now for the big ideas, I think you will have to write similarity statements for the first couple problems, just to test whether you understand how to break them apart. So that will be one. But the rest of them, if you remember these, you'll be able to solve whatever they need in the triangle. Okay? There's one in February, there's one in April, there's one in July.
What's the one that we took in school?
April. But it's not the national one. The state does its own. So there's 2 you could do in April. My kids, I always made them take the second one because we prep you so hard for the state one, you're ready to go on the national. So you really get 2 tries with the same prep. Does that make sense? Because both tests you can send to colleges, the state one and the national. The state one you're required to do through the school, and so that's paid for. The national one you pay for. But if you're, yeah, if you're prepped and ready to go for the state one, you might as well try your hand at both of them, and then hopefully get a better score than you'll, on one or the 2.
Was that one in November or whatever national?
Every other one is national except for the April one.
Okay.
Yeah. Okay, let's go through the textbook check real quick. All 3 triangles in this figure are similar to each other. True. In the equation below, x is called the geometric mean. What is the geometric mean of 25 and 36? Well, what did I tell you to do? Rather than multiply them together, just take the square root of both, right? So square root of 25 is 5, square root of 36 is 6, 5 times 6 is 30. So the geometric mean is 30. Use the one of the geometric mean theorems to solve for x. So this is going to be a leg, right? So it's going to be the geometric mean of the side closest times the whole length. Well, the side closest is 20, and the whole length is 35, right? Square root of 20 times the square root of 35. Square root of 20 is 2 square roots of 5 times the square root of 35, right? 35 times 5. What is that? 70, 140, 175? 175? 35 times 5? Huh. Is there a perfect square that goes into this? What are your perfect squares? Give me the first 5. 1, 4, 9. How do you get them? You just take the first 5 numbers and square them. 1, 4, 9. What's 4 squared? What's 5 squared? Okay, do any of those 5 numbers you just gave me go into 175 evenly? Yes, 25 does. I'm not trying to figure this out, but okay. 25 goes in evenly. It's 25 times what? Okay, so I have 2 times the square root of 25 times the square root of 7. Square root of 25 is 5. 5 times 2 is 10. 10 square roots of 7. Okay. The other way you could have done it, this times this is 700, right? What's a perfect square that goes into 700? What's 10 squared? 100. Does 100 go into 700? Same thing. Okay, so the square root of 700 was an answer, but it's not the right one because 10 square roots of 7 is simplified. They both have the same. If you were to take 10 square roots of 7 and the square root of 700 in your calculator, you get the exact same answer. But you must simplify it to 10 square roots of 7. Okay, and then finally, question 5. In the second video, she used a square inscribed in a circle for the example problems. You're shaking your head no? Who got this one right? And you said false. So there it is. Okay. Big Ideas is open, so is CK12. Yes, what question? Yeah, I know. Okay. Give me a problem.
I'll have on a wall, will a 20-foot ladder touch if the ladder is placed 8 feet from the wall?
Okay, so here's my wall. Here's the ladder, and the foot of the ladder is 8 feet from the wall. 8 feet. And what length is the ladder? 20?
20, yeah.
So this is the ladder. There's my right angle. And I'm wanting to know this. Pythagorean theorem. A squared plus b squared is c squared, and then solve. If I call this x, x squared plus 8 squared equals 20 squared. So x squared equals 20 squared minus 8 squared. So x is equal to the square root of so 400 minus 64 in the square root. Okay, any others?
It says, this is probably easy, but find the distance between the coordinates 0, 0, and -2, 5.
0, 0.
Answer to the nearest, or to the nearest one.
Okay. 0, 0, and -2, 5.
Yeah.
Okay, so this is just the triangle method. If I want to find the distance between them, it's the hypotenuse. This is 2, this is 5. So how do I find the hypotenuse of a right triangle? 4 plus 25 is 29, so it's the square root of 29. So you put that in your calculator and you round it to the 100th.
So there, 41.
The square root of 29, you got what?
841.
No, not 29 squared,
Or squared.
the square root of 29.
5.3.
Okay?
Says how much more?
What were the give me the coordinates again?
0, 0, and -2.
-2, 5.
Yeah.
So it's a squared, which is 4, plus 25 is 29, square root of 29. Well, you've got to round it to the nearest 100th. Any others before I stop recording? Nope.